Hello everyone, this is Reddy, Assistant Professor in Mathematics, and the subject is DEVC, Differential Equations and Vector Calculus. The topic will be Ordinary Differential Equations of Higher Order, right? So, in the earlier class, we already discussed about this, and again, briefly, we are discussing this. So, what is the general form? The nth order differential equation of the form, that is d power n into y by dx power n plus a1 into d power n minus 1 y by dx power n minus 1 plus a2 into d power n minus 2 y by dx power n minus 2 plus so on that is plus an into y equals to q of x. This is the general form of the nth order linear differential equation with constant coefficients. In the earlier class, we already discussed how to find the complementary function. Now we are going to discuss how to find the particular integral. That means the general solution of the first order is general solution of this type of differential equation will be, that is y equals to cf plus pi. Here cf will be the complementary function. We already discussed how to find the complementary functions in earlier session, and now this session we are going to discuss how to find a particular integral, right? So when we will find a particular integral, whenever the right hand side function q of x, this is a non-zero function, which is non-zero, identically non-zero, means there will be some functions in terms of independent variable x, like exponential, like a trigonometry, like logarithm, like mixing of all the functions. So whenever this will be something in the right side, then we are going to find the particular integral. In the first session, we are going to discuss if the case the function will be q of x, if it is the exponential function, then how to find the complementary function, how to find the particular integral, that we are going to discuss, right? So here we are going to discuss working rule to find a particular integral for whenever f of x is equals to e to the power of ax, right? So pi equals to 1 by f of d into e power of ax, that equals to 1 by f of a into e power ax. Just here you can replace d by a, when replace d by a. If it is the value will be the solution whenever the denominator is non-zero. Whenever denominator is non-zero, then it will become our required solution, right? Okay. If it is the case, the denominator f of a becomes 0, then the value can write this is equals to 1 by f of d into e power of ax, that equals to x into 1 by f dash of a into e power of ax. This is the value whenever the denominator f of a becomes 0, right? Again here the value f dash of a, the value is non-zero. F dash of a is non-zero. Again, if it is the f dash of a is also becomes 0, then pi becomes x square into 1 by f double dash of a into e power of ax. Again, this will become the solution whenever f dash of a value becomes 0. Again, in this case here, since here f double dash of a is also again non-zero value. If it is again 0, then you can proceed, keep on continuation, right? Next. So using the above working rule, we are going to solve the differential equation. The example will be here, d square y by dx square minus 2 into dy by dx plus 10 into y equals to e power 2x. This is a given differential equation. We are going to find the solution for this differential equation. And here you can observe the equals to e power 2x. In the right side, some function will be there, that is the exponential function, whereas a equals to 2. Okay, so we already know how to find a particular integral whenever the right side function will be e power 2x. Now let's start how to find the general solution for this equation. Right, solution. So your given differential equation is that is d square minus 2d plus 10 into y equals to e power 2x. Here I am writing the given differential equation in operator form, right? Whereas d equals what? D by dx. Now here I am writing this as f of d into y equals to e power 2x. Whereas f of d is what? F of d, that becomes d square minus 2d plus 10. Now taking the auxiliary equation A, that is f of m equals to 0. Then m square minus 2 into m plus 10, that equals to 0. Now here we need to find, this is a second order algebraic equation or is a quadratic equation. Here we need to find the solution for this. So then m equals to minus of minus 2 plus or minus square root of minus 2 whole square minus 4 into 1 into 10 by 2 into 1. Then 2 plus or minus square root of 9 minus 40 by 2. Then 2 plus or minus square root of minus 36 by 2. Continuation here, that equals to 2 plus or minus square root of minus means I, that will be a complex number, and square root of 36 will be 6 by 2. Here you can take common 2, then 1 plus or minus I 3 by 2. By 2 and 2 cancels, then 1 plus or minus I 3. That is the complex root. That will be in the form of alpha plus or minus I beta comparing with alpha equals to 1 and beta equals to 3. Then the CF you can write e power of alpha x, that means 1 into x, into C1 cos beta cos 3x plus C2 sin 3x. This becomes our required complementary function only. The next we are going to find the particular integral, right? Okay, now let's start finding the particular integral. That is 1 by f of d into whatever the right side function is given, take the function is here. What is the right side function here? E power 2x, right? So e power 2x, this is equals to 1 by f of d. What is f of d? What is f of d? That is the d square minus 2d plus 10. D square minus 2d plus 10 into e power 2x. So what is the working rule? Here you can replace d by a. Here what is exponential power e power of ax, right? So comparing with a equals what? 2. So here a value will be 2. Now replace d by 2. So then we'll get 1 by 2 whole square minus 2 into 2 plus 10 into e power 2x. Here you can observe the value a equals to 2, that is a root or not. If it is a equals to 2 is a root, then the denominator will become 0. Otherwise, it is a non-zero value. Right. E power of 2x. This is equals to 1 by 2 square means 4 minus 4 plus 10 into e power 2x. So plus 4 and minus 4 cancels, the remaining is 1 by 10. 1 by 10 into e power of 2x. That's it. This will be value will become the required particular integral. So therefore, the general solution of 1 is y equals to CF plus PI. That y equals to e power of x into C1 cos 3x plus C2 sin 3x, and plus Pi will be 1 by 10 into e power 2x. This is our required solution. Is the required solution. Where C1 and C2 are arbitrary constants. C1 and C2 are arbitrary constants. Right? Now let's go for one more example. This is one more example. It is also, again, the right side function will be e to the power of x. So then how to find the solution? Same procedure. Solution. Given a differential equation is d square plus d minus 2 into y equals to e to the power of x. Here directly I am writing the operator form. Okay, right. Next, f of d into y equals to e power of x, whereas f of d equals to d square plus d minus 2. Now take the auxiliary equation. F of m equals to 0. Then m square plus m minus 2 equals to 0. Now this will become the quadratic equation. Now you can find the roots, whatever the methods you know. Here I am going to find the roots using this. So 1 plus or minus square root of 1 square minus 4 into 1 into minus 2 by 2 into 1 equals to 1 plus or minus square root of 1 plus 8 by 2, because minus 4 into minus 2, minus 4 minus 2 minus 8, minus or minus plus, so becomes plus 8. Now its value becomes 1 plus or minus square root of 9 by 2, again equals to 1 plus or minus square root of 9 means 3 by 2. Then 1 plus 3 by 2 or 1 minus 3 by 2. 1 plus 3 by 2 means 2, or 1 minus 3 by 2 means minus 2 by 2, minus 1, minus 1. So therefore the roots will be m equals to minus 1 comma 2. These are the both will be both are real numbers and distinct. Therefore, the CF is given by C1 into e power minus 1 into x plus C2 into e power 2 into x. This is our required complementary function for the differential equation. Next, we need to find the particular integral with respect to the function e power of x. Next, let's move on to the next board. Pi 1 by f of d into e power of x equals to 1 by f of d. What is f of d? D square, just go back, minus d square plus d minus 2. D square plus d minus 2 into e power of x. So this is a exponential function, whereas a equals to 1. So what is our working rule? You can replace d by a. You can replace d by a. So in the denominator, before replacing the value, d equals to a, that means 1. Before you're going to check, 1 will be the root or not. If it will be the root, then the denominator will be get 0. So here we observe the roots are only -1 and 2. So here 1 is not a root. So it becomes, you can replace d by 1. Then that equals to 1 by 1 square plus 1 minus 2 into e power of x. Here the denominator you are getting this, the value will become 0. Right? So if the denominator becomes 0, then what is the working rule? Then this is equal to x into 1 by f dash of a into e power of x. So what is f dash? 1 by derivative of d square will be 2d plus 1 into e power of x. Now replace d by a. Now d replacing by 1 equals to x into 1 by 2 into 1 plus 1 into e power of x. This is equals to x into 1 by 3 into e power of x. Finally, x e power of x by 3. This will be the our required pi. Now finally, the general solution. Therefore, the general solution of 1 is y equals to cf plus pi. That equals to, what is cf? c1 e power of minus x plus c2 e power of 2x plus pi will be x e power of x by 3. That's it. Is the required solution. Is the required solution, where c1 and c2 are arbitrary constants.